Hi everybody, if here is a rectangle ABCD and we inscribe a circle that is tangent to three sides of the rectangle, and we inscribe another circle that is tangent to this bigger circle and one side of the rectangle, and we also inscribe two yellow circles that are tangent to these two bigger and smaller circle and two sides of rectangle. If ABCD is a rectangle and yellow circles are identical, then we have to find ratio of length of altitude by length of base. I saw this problem on Brilliant. Now we are on the official site of Brilliant and we go to community, and here in difficulty we get it hard, and in popularity we go to following, and in topics we go to geometry, and the third question is the question that I choose. And if we go to discuss solutions, you get there are two solutions over here, and in both solutions they consider the width of the rectangle be 1, and in the solution above we also consider width of the rectangle be 1. But looking at this question is in the category of hard, and considering the width of the rectangle equals to 1 make it really average, but we will solve this without considering the width of the rectangle is equals to 1, and that's make it really hard. Now here is our question, and note that the real challenge is to find the answer without assuming any side be a real number. So please give your trial to this question and keep watching for the solution. So before I will tell you the solution, we need to prove our result. So if here is a bigger circle and here is a smaller circle, and these both circles are tangent at a point, and we draw a line that pass through the same tangential point, and let this point be B. Now let the center of the bigger circle be O and center of the smaller circle be O dashed. Now pass the line from this point O to this tangential point, and similarly from this smaller circle pass the line to the tangential point from center. We know that radius is perpendicular to the tangent, so this angle is also perpendicular and this angle is also perpendicular. Now I vanish these circles, and you can see this line O dash is 180 degrees, and this makes it a complete straight line. So whenever you see two circles and if we join their centers, then this line is a complete straight line that passes through their tangential point. And this is a result that we use many times in our question. Now here is our figure. Now on the left topmost circle, which is our yellow circle, draw the radius to the tangential point, so and it is perpendicular, and also on another side and it is also perpendicular. Let the radius of left side yellow circle be R1, and we know that this is rectangle, so this angle is also equals to 90 degrees, so this line be R1, and similarly doing this on the right side we get this side is also equals to R1. Now also drop the radius of the smaller circle to the tangential point and join the centers of these two circles. So by our this result we can say this is a straight line that passes through the tangential point, and let the radius of the smaller circle be R2. So this complete line is R1 plus R2. Now looking in this figure is a trapezium, so we can see if we drop a perpendicular to the base, this side be R2 and this side is R1 minus R2, and using Pythagoras theorem, so we have R1 plus R2 whole square is equals to R1 minus R2 whole square plus altitude square. So we have altitude is equals to 2 under root r1 times r2. So we have altitude is equals to this. So this side is also equals to 2 under root r1 times r2. So looking in our figure, this side be 2 under root r1 times r2, and this side is also equals to 2 under root r1 r2 if we do this same thing on the right side. Now in the bigger circle, from the center, drop the radius to the tangential point, and this is a complete straight line, and let the radius of the bigger circle be r3. So over this side, which is the width of the rectangle, be 2r3, and also drop the perpendicular to the lowermost tangential point. So we have radius is equals to r3, and if we join the centers of bigger and smaller circle, this by this theorem, this is a straight line, and this complete line is also a straight line. So our length of the rectangle is equals to 2r2 plus r3. Now drop the perpendicular from the left topmost yellow circle to the radius of the bigger circle, and join the centers of yellow and bigger circle, and by our this result, this is a straight line that passes through the tangential point. So radius of smaller yellow circle be r1 and radius of bigger circle is r3, and our base is r3 minus r1. And so by Pythagoras theorem, our altitude as well as this side is also equals to 2 under root r1 times r3, and this side is also equals to r1, and our this side is equals to r3. So our this complete side is r1 plus r3 plus 2 under root r1 times r3, and our topmost length is 2r1 plus 4 under root r1 times r2. Now we minimize this figure, and we know that opposite sides of the rectangle are equal. So by this, 2r1 plus 4 under root r1 times r2 is equals to 2r3. So we have r1 plus 2 under root r1 times r2 is equals to r3, and let this be our equation first, and similarly 2 times r2 plus r3 is equals to r1 plus r3 plus 2 under root r1 times r3. So we have 2r2 plus r3 is equals to r1 plus 2 under root r1 times r3, and let this be our equation second. Now we have these both equations. So substituting the value of r3 with this, so we get this. Now cancelling r1 with r1 on another side, so we get r2 plus under root r1 times r3 is equals to under root r1 times r2. Now we have this and take r under root r1 as common, so we have r2 by under root r3 minus under root r2 is equals to under root r1, and we use this value by substituting the r1 in our equation first. So this is our first equation, and this is the value of r1 that we found. So putting the values, so we get this, and this is also written as this, and using a minus b whole square formula and taking the LCM, so we get this, and again opening the parenthesis, so we get this. Now we make it in a more simpler way, so we get this, and from LHS side take 2 under root r2 times r3 as common, and from this term use the reverse of a plus b whole square formula, so we get this. Now write it in on a more simpler way, so we get this. Now let r2 plus r3 is equals to x, and under root r3 times r2 is equals to y, and substituting the values, so we have 2yx is equals to x square minus y square. So we have 0 is equals to y square plus 2yx minus x square. Now consider y as variable, and using quadratic formula, which is equals to y is equals to negative b plus or minus square root of b square minus 4ac over 2a and putting the values, so we get this. And now make it in a more simpler way. So we have y is equals to x times minus 1 plus or minus under root 2. Now putting the values of y and x, so we get this. Now let alpha is equals to negative 1 plus or minus under root 2 and putting the alpha and squaring both sides and using a plus b whole square formula, we get this. And now make it more substitutions, and from the middle side take r2 as common, so we have r2 square alpha square plus r2 times 2r3 alpha square minus r3 plus r3 square times alpha square. Now consider r2 as variable and use quadratic formula again. So r2 is equals to this and putting the values, so r2 is equals to this and using a minus b whole square formula, so r2 is equals to this and cancelling them, and from the whole term take r3 as common, so we have r2 is equals to r3 times negative 2 alpha square plus 1 plus or minus under root of 1 minus 4 alpha square by 2 alpha square. And this is the value that we have to find. So r2 is equals to r3 times this all stuff, and looking in our original figure, we need to find length of altitude by length of base, which is equals to 2r2 plus r3 by 2 times r3 and cancelling 2 by numerator and denominator and putting the value of r2 that we find, so we have this. Now take r3 as common, so cancelling this r3 with this r3 in numerator and taking the LCM, so we get this. Now cancelling this, so the final term we have length of altitude by length of base is equals to 1 plus or minus under root of 1 minus 4 alpha square by 2 alpha square, and we know that alpha is equals to negative 1 plus or minus under root 2. Now if alpha is equals to negative 1 minus under root 2, then 1 is smaller than 4 alpha square, and this leads to this whole ratio in the complex number, and this is not possible. So considering alpha is equals to negative 1 negative under root 2 is completely wrong. So now alpha is equals to negative 1 plus under root 2. Now in the first case, consider the value of plus in the place of plus or minus. So this gives us the approximate value of ratio, which is equals to 4.55, and in second case consider the value of minus. This gives the approximate value, which is equals to 1.281971 and so on. But which value of ratio we consider, because both are positive. So now looking on the first case, the ratio is 4.55, and suppose we make a rectangle and the base is 1, then by our ratio the length is 4.55, and if we inscribe a smaller circle at the bottom of the rectangle, and by our figure we inscribe another circle at the topmost part of the bigger circle, then we doesn't have enough space to inscribe two yellow circles of same radius which is tangent to this blue circle and also this bigger circle at the bottom of the rectangle. So considering the ratio is equals to 4.55 is completely invalid. So the correct value of ratio is equals to 1.281971 and so more, and that is our correct answer.